Hello, the half-angle formulas are sine of x over 2 equals plus or minus square root of 1 minus cosine of x over 2, cosine of x over 2 equals plus or minus square root of 1 plus cosine of x over 2, and for the tangent we have three formulas. The first one is tangent of x over 2 equals plus or minus square root of 1 minus cosine of x over 1 plus cosine of x. The second one is tangent of x over 2 equals sine of x over 1 plus cosine of x. And the third is tangent of x over 2 equals 1 minus cosine of x over sine of x. As you see, in each of these formulas, the trigonometric functions to the left use the angle x over 2, which is half the angle of the trigonometric functions that are used to the right. In this video, I will explain each of these formulas, including the plus and the minus sign in front, and I will also solve a few examples. So let's start with the half-angle formula for sine. To derive this formula, we will need the power-reducing formula. So here we have it, and this is sine squared of theta equals 1 minus cosine of 2 theta over 2. And I will leave a link in the description below if you will want to watch a video that explains the power-reducing formulas. Now here we will take this formula and we will solve it for sine of theta. And for this we will use the square root property, so when we drop the exponent 2 on the left side, then on the right side we will write plus or minus square root of this expression. So we will have sine of theta equals plus or minus square root of 1 minus cosine of 2 theta over 2. And notice that on the left side sine has theta, but on the right side the angle doubles and cosine has 2 theta. Now in this formula, let's replace each theta with x over 2. Then we will have sine of x over 2 equals plus or minus square root of 1 minus cosine of 2 times x over 2 all over 2. Then in this formula, 2 and 2 will cancel, and we will write that sine of x over 2 equals plus or minus square root of 1 minus cosine of x over 2. And this is the half-angle formula for sine that we have above. Now let's talk about the plus and the minus sign we have in front of the radical. Depending on the quadrant in which x over 2 lies, this expression will have either a positive or a negative in front, but not both. For example, let's apply this formula to evaluate sine of 22.5 degrees. Because this angle is in quadrant 1, and in quadrant 1 sine is positive, then we will have a plus sign in front of the radical. So sine of 22.5 equals positive square root of 1 minus cosine of double angle, which is 45 degrees, over 2. And from the unit circle, cosine of 45 degrees is square root of 2 over 2. Then we will have square root of 1 minus square root of 2 over 2, all divided by 2. And after a few more steps, we will have square root of 2 minus square root of 2 over 4. And this is approximately 0.38. Now, what if we need to evaluate sine of 210 degrees? This angle is in quadrant 3, and in this quadrant, sine is negative. Then in this case, we need a negative in front of the radical. And inside the radical, we will have 1 minus cosine of double angle, which is 420 degrees all over 2. Now 420 degrees is a sum of 360 degrees and 60 degrees. And because the cosine function is a periodic function and the period is 2 pi, which is 360 degrees, then we can drop 360 degrees and we can say that cosine of 420 degrees is the same as cosine of 60 degrees. So we will write negative square root of 1 minus cosine of 60 degrees over 2. Then from the unit circle, cosine of 60 degrees is 1/2. So now we will have negative square root of 1 minus 1/2 divided by 2. And 1 minus 1/2 is 1/2 divided by 2 is 1 over 4. Then we will have negative square root of 1 over 4, which equals negative 1/2. So as you see, depending on the quadrant in which these angles lie, we will have either a positive or a negative sign in front of the radical. Now let's talk about the half-angle formula for cosine. This one is derived from the power-reducing formula for cosine. This formula is cosine squared of theta equals 1 plus cosine of 2 theta over 2. If we solve this formula for cosine, then we will have cosine of theta equals plus or minus square root of 1 plus cosine of 2 theta all over 2. In the next step, we will replace each theta with x over 2. Then we will have cosine of x over 2 equals plus or minus square root of 1 plus cosine of 2 times x over 2 all over 2. Then under cosine 2 and 2 will cancel and we will have cosine of x over 2 equals plus or minus square root of 1 plus cosine of x all over 2. And this is the half-angle formula we have above. And just like before, depending on the quadrant in which x over 2 lies, this expression will have either a positive or a negative sign in front, but not both. For example, let's say we have cosine of 300 degrees. This angle lies in quadrant 4, and in quadrant 4, cosine is positive. Therefore, in front of the radical, we will have a positive sign. So we will have positive square root of 1 plus cosine of double angle, which is 600 degrees, all over 2. And eventually, if we simplify more, this expression will be equal to 1/2. Now, what if we have cosine of 120 degrees? This angle is in quadrant 2, and in quadrant 2, cosine is negative. Therefore, in front of the radical, we will put a negative. Then we will have negative square root of 1 plus cosine of double angle, which is 240 degrees, all over 2. And this will be equal to negative 1/2. And now let's talk about the half-angle formulas for tangent. Here we have 3 of them, and the first one is derived from the power-reducing formula for tangent. This formula is tangent squared of theta equals 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. If we solve this formula for tangent, then we will have tangent of theta equals plus or minus square root of 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. And now let's replace each theta with x over 2. Then we will have tangent of x over 2 equals plus or minus square root of 1 minus cosine of x over 1 plus cosine of x. And this is the half-angle formula that we have above. And again, depending on the quadrant in which x over 2 lies, this expression will take either a positive or a negative sign in front, but not both signs. Now, what about the other two formulas? We have a few different methods of proving them, and one approach to derive the first formula is to write tangent of x over 2 as sine of x over 2 over cosine of x over 2. In the next step, we will multiply both the numerator and the denominator by 2 cosine of x over 2. Now we will have tangent of x over 2 equals 2 sine of x over 2 times cosine of x over 2 all over 2 cosine squared of x over 2. Now we need to use a few formulas. In the numerator, we will apply the first formula, and in the denominator, we will apply the second formula. Both these formulas are called double angle formulas. And the first one is 2 sine of theta cosine of theta equals sine of 2 theta. So in this formula, whatever angle is on the left side, this angle has to double on the right side. In our numerator, we have 2 sine of x over 2 cosine of x over 2. If we apply this formula, then this expression becomes sine of 2 times x over 2, which is sine of x. So we will have tangent of x over 2 equals sine of x over, and now in the denominator, we will apply this formula, and the denominator will become cosine of x plus 1. So again, if we replace this theta with x over 2, then on the right side, we will have x. And this is the half-angle formula that we have above. Now, in the last formula, again we will start with tangent of x over 2, and we will write it as sine of x over 2 over cosine of x over 2. And here we will multiply both the numerator and the denominator by 2 sine of x over 2. And now we will have tangent of x over 2 equals 2 sine squared of x over 2 over 2 cosine of x over 2 times sine of x over 2. And now again we will use the double angle formulas. In the numerator, we will apply 2 sine squared of theta equals 1 minus cosine of 2 theta. And in the denominator, we will apply 2 sine of theta cosine of theta equals sine of 2 theta. Now keep in mind that in these two formulas, I rearranged the terms to fit our problem. For example, this one initially was cosine of 2 theta equals 1 minus 2 sine squared of theta. Now, if we use this formula in the numerator and we replace theta with x over 2, then on the right side we will have 1 minus cosine of x. So now we have tangent of x over 2 equals 1 minus cosine of x And now if we apply this formula in the denominator and replace theta with x over 2, then on the right side we will have sine of x. So now the new denominator is sine of x. And this is the half-angle formula that we have above. So now we have all three half-angle formulas for tangent. Thank you for watching the whole video, and please give me a like and subscribe if you find this channel useful.